Hello and welcome to the Workflow Academy. In this comprehensive Platform Academy video series, we'll dive into the transformative world of workflow automation, empowering you to build, monitor, and optimize efficient workflows with ease. Join us as we explore the core tools of ServiceNow's workflow automation suite to build flows and subflows, playbooks, and decision tables on the Now platform. My name is Lisa Hohenstein, and I work as an outbound product manager for the Now platform. My area of expertise is workflow automation, and I create enablement content, videos, articles, and blogs on the Now community. I have been with ServiceNow for almost 6 years, and I have been part of the ServiceNow ecosystem since 2016. Before joining ServiceNow, I was a platform owner, admin, and developer at a customer. In today's video, we will talk about loopings. Not the ones on a roller coaster, but the different ways of looping back in flows and playbooks. When building workflows on the Now platform, you will come across many use cases and scenarios where you just need to try and try again. This session will help you understand which design patterns work best in which scenarios and what to consider when looping back. Quick reminder, I may mention coming releases or product features that are still in development. All timelines and features may be subject to change, so please don't make any purchasing decisions based on anything I say today. Today, we will start with some basic information on loops, as well as some system properties and flow settings you need to know. Next, we look at different ways of loops for flows and subflows, how to best use them, and what to avoid doing. In the third part, we cover the restart feature for playbooks, how to configure activities and stages, and look at some use cases. And lastly, I will go through some guidance and recommendations about loops in workflow automation. Alright, so let's start with some looping basics. Loops are a fundamental concept in both coding and low-code workflows. They are used to repeat a set of actions or tasks multiple times until a certain condition is met. All loops consist of 3 parts. There's the start, whatever initiates the loop. There's the action that is executed during the loop, possibly repeatedly, and then there are exit conditions. Let's look at different types of loops. The for loops. Imagine you have a list of items, like a grocery list, and you want to check off each item one by one. A for loop helps you go through each item in the list, performing the same action, that is checking off, for each one. This is useful when you know exactly how many times you need to process. Second, while loops. Now think about a scenario where you want to keep watering your plants until the soil is moist enough. A while loop allows you to keep performing the watering action as long as the soil is dry. It's useful when you don't know in advance how many times you'll need to repeat the action, but you have a condition that tells you when to stop. Third, do until loops. Now imagine you want to keep rolling a dice until you get a 6. A do until loop ensures that you roll the die at least once and then keep rolling until you get the desired result. This type of loop guarantees that the action is performed at least once, regardless of the condition. In workflows, loops can be used to automate tasks like sending reminder emails until a response is received, processing batches of data until all data is handled, or repeatedly checking for updates until a certain condition is met. They help streamline processes, reduce manual effort, and ensure consistency in repetitive tasks. As you may already understand from the use cases I just described, it is paramount for the performance of your instance that you always provide valid exit conditions from any loops you build. As a failsafe, there are different system properties and flow settings that protect your instance from infinite looping. The maximum number of iterations property applies to the do the following until and go back to flow logics. The default value is 1000, and we strongly recommend to not increase this beyond 1000. The second property you find here is a protection against recursion, which means there is a limit on how often a flow or subflow can call itself. The default value is 3, again with a recommendation to not increase this. If you are looking to run a specific piece of logic again, we recommend to use the do the following until logic over calling a subflow from itself. Next to infinite loops and recursion, the third thing to consider when looping is that you want to minimize the performance impact on your database by only storing necessary reporting and execution details. By default, all flow executions with loops only store execution details for the first and last iterations of a loop to prevent any impact. Prior to the Xanadu release, we had a global property to control this behavior. Sometimes you need to debug a specific flow or subflow on a subprod instance, but you don't want to turn this on globally. With the newly introduced flow setting that you can find on the sysflow execution setting table, it is now possible to turn on reporting for all iterations per each flow. Use this carefully and remember to turn it back off before you deploy your flow to prod. As a pro tip, create an instance scan definition to run on update sets to catch any flows that have this enabled. Now that we have learned about loops in general and available properties and settings, let's look at specific design patterns available for loops and flows. For those of you who have been working on the Now platform for a while, you might know that when building legacy workflows, you can drag the connecting line from an activity, presumably from an if condition branch, to an earlier step to re-execute all steps in between. When building flows, there's no interacting with the canvas in the same way, but we can achieve the same goal by using the go back to or do the following until logics. To enhance this functionality for legacy workflows containing tasks and approvals, you can use the rollback action, which will set all approvals between it and the loopback target to not yet requested, and reset all tasks to open or pending. When the execution returns to these records, they will be re-requested and tasks must be worked from the start. For flows and the go back to logic, this works a little differently, and we'll walk through some examples in the next couple of slides. My first example is an approval being rejected with the option to submit for approval again. Be very mindful with use cases like this and only use it if this pattern is absolutely required and accepted by the process stakeholders. The default design would be to cancel a request upon reject and have the requester submit a new request with correct inputs. However, I know that these scenarios exist, and I want to give you some guidance on how to build this in a more sustainable manner. When you build a loop like this, it should include some way for the requester to update the original request or requested item before looping back. You should always specify valid conditions to exit the loop, either to successfully execute the remaining main path of the flow or ending the flow with canceling the request. For loops that contain manual steps, be that tasks or approvals, we recommend to limit the number of iterations to a maximum of 3 with the help of a flow variable. Be mindful of how far back you choose to go to avoid unnecessary duplication of task work. We also recommend to use the wait option on created tasks to wait for their completion before using the go back to logic. If tasks are created but not completed, consider adding steps to look up and cancel all open tasks before going back to avoid stale tasks. The ask for approval action will simply create new approvals that will need to be processed. One note, once you add the go back to logic, you can no longer drag and drop to reorder flow steps. So build out as much of your flow as you can before adding the go back to logic. For the second example, we are using a loop to walk up a parent-child type relationship between records until we reach a record with no parent entry or a given condition is met. This can be done either with go back to or do the following until. We'll look at both scenarios here. This design can be used to look up managers with a certain title, go up the cost center hierarchy until a specified level, or find a specific department in your organizational hierarchy, and many, many more. For both patterns, we will use a flow variable to store the next record to evaluate, and a condition to determine whether we met the necessary requirements or found the end of the chain. If your instance is not yet upgraded to Xanadu, you cannot use go back to for existing flows just yet, but the do the following until flow logic works perfectly for this scenario as well. Here we define the exit condition in the until section of the flow logic, where we have access to any fields within the loop as well. Do until loops are sometimes so quickly executed that it is recommended to add a wait for timer between the iterations, so we don't run into the max iterations property, especially when you're looping over an integration step. Another perfect example for adding a wait for duration within the loop is in combination with the try flow logic to build robust error handling. Any flow action or subflow that might run into an error should be wrapped in a try logic or caught with some steps on the flow error handler. The try logic alone does not try repeatedly, but if you add go back to or do the following until, you can try an action integration or subflow until it executes successfully. Following the design pattern we know from action retry policies, we can use a flow variable to determine the length of the wait for duration timer and increase the duration on each loop. To learn more about error handling for flows and actions, check out my article series on the community and the corresponding Academy episode. Something we have seen customers do is using a do until to wait for a record field to change. We recommend to use the wait for condition instead, or choose one of the alternative patterns on the right. Except for the first scenario, the use cases on the left here are generally valid design patterns and can be used for flows that will be completed within a couple of days. However, for longer running flows, we recommend either of these two options. First, end the current flow and trigger a new flow from the record or a date condition that you would be waiting for instead. For more complex workflows, explore Playbooks to connect the dots in longer running, multi-stage processes. Scheduled flows are also very useful to ensure time-based reminders or flow execution. Customers often like to build loops to check for approval state or task completion and sending reminders to the assigned to. Especially for task-based work, SLA flows are best suited to cover reminder notifications and escalation needs while ensuring keeping agreed-upon service timelines. If SLAs are not a solution for your use case, consider creating a scheduled flow to look up all outstanding approvals or tasks per user and sending one notification per day or week instead of individual notifications for each record. So let's look at a few examples of what to do and what not to do. First up, you have a process where child records are created for your current record, and you want to update the parent once all child records are completed or canceled. While it seems intuitive to build a loop that checks for, in this example, all incident tasks that are connected to the current incident, and then continue once none of them are active anymore, this is not a good design pattern. The better design is to have a separate flow that triggers when an incident task is closed or canceled. Then you can look up all sibling incident tasks that are also connected to the parent incident. If no records are found, this means all incident tasks have been closed or canceled, and you can perform whatever update you were planning to do for the parent record. The second use case sends an email or notification when a given due date is 7 days away. If the due date on the record is changed in the meantime, this change will not be caught and the flow will continue based on the original due date. To account for possible changes to the date field, we recommend to build a scheduled flow instead to check for all catalog tasks where the due date is less than a week away or overdue and not completed yet. As a quick tip, consider using system notifications instead of sending one-off emails from flows. This allows you to enable them for digests so that the recipients can get one email per day or week instead of individual notifications for each record. Another loop you can avoid easily is when you are waiting for a given record to reach a specific state or a field to be updated. Instead of doing do until or go back to here, you can do one of three things. First, use the wait for condition action. This will create a record watcher and wake up the flow execution once the condition is met. Use this for a somewhat shorter wait for scenarios. Second, end your flow and create a new one that triggers off the given condition. Use this pattern for use cases where the wait for might exceed a week or two. Third, consider creating a playbook for these more complex and longer running processes. Playbooks also offer a wait for condition activity. Plus, you can run activities or stages with a delay for those use cases where you already know that some time will pass between them. This also brings us to our final type of loop today, the Restart Playbooks feature, which was introduced in the Washington, D.C. release earlier this year. When you open a playbook that was created prior to Washington for the first time after upgrading the store apps, you will be prompted to enable it for restart. This setting is also found in the playbook properties. After enabling restart, you can then decide the restart rules for each stage and activity. The default setting is skip on restart, and you can see a tooltip on both board view and diagram view if an activity or stage is set to either of the other options. Here are some considerations to make when using restart in playbooks. Restart can be used on an activity or stage, but only once it has been completed. A playbook can be restarted at any time while it is still running. Playbooks that are in a complete, error, or canceled state cannot be restarted. Avoid setting the last stage or activity of a playbook to skip on first run if there are no parallel stages or activities. If the playbook is restarted before that last stage or activity can run, that stage or activity will never run. We also recommend to avoid grouping all activities that are configured to skip on first run in one stage. If you do so, the stage is completely hidden the first time that it runs, and the stage must run twice to become visible. When you restart a stage or playbook, any in-progress activities will be set to canceled. This change can be used to clean up any pending tasks or approvals before new tasks or approvals are created when the activity runs on the next iteration. Several baseline activities that we provide already include logic in their execution plans to support this cleanup. For example, the Request Manager approval activity. We created a parallel path with two wait-for conditions. In the first, on the right, we wait for the approval record to be approved, rejected, canceled, or set to no longer required, which in turn leads to the activity to complete. On the second path, on the left, we wait for the activity to be updated from the outside, for example, being canceled from a stage or playbook restart. In that case, the pending approval record will be updated to no longer required. To demonstrate the playbook restart feature, I have updated the application approval playbook to run always except for the first stage. In the first stage, we create a new customer account and add the customer to the application. On restart, that customer record would already exist, thus eliminating the need to create a new one. As you'll see in the demo recording, the first stage is only executed once, but the approvals on the second stage will be triggered every time. Any approvals that are pending when I restart the playbook are set to no longer required. If you want to learn more about playbooks, check out my YouTube playlist with all the Workflow Academy sessions that cover playbook topics and the Center of Excellence on the Now community. So let's revise what we learned about loops today. Keep these points in mind while building out your workflows. All loops should have one or more valid exit conditions to avoid infinite loops. Only turn on the option to report on all iterations when debugging flows on subprod instances. Similarly, we generally recommend to keep reporting off on production instances to reduce memory consumption and maintain swift execution times. For business-critical flows, you can individually turn on the basic reporting setting per flow. As mentioned on a previous slide, it is best to avoid indirect recursion by not calling a flow or subflow from itself. When building loops within a flow, we recommend to keep these loops small to avoid unnecessary duplication of manual work. Consider building playbooks for larger scale processes and utilizing restart rules for well-defined repetition of activities or stages. Lastly, also in the spirit of keeping loops small, use conditions and flow variables to reduce the total number of iterations where applicable, and don't increase the maximum number of iterations past 1,000 globally. Thank you for staying with me so far. Your feedback is invaluable. Please take a moment to fill out our survey or leave a comment on the community article to share your thoughts. And if you like this session, please upvote this video. If you're interested in other topics beyond workflows, let me recommend my Colleagues Academy series. Each of them covers a different part of the Now platform, including analytics, experiences, and artificial intelligence. While on the topic of more content, if you prefer to read up on topics at your own pace, check out the Workflow Automation Center of Excellence on the community. I've collected resources and links, and I'm regularly publishing new articles with best practices, FAQ, and guidance around flows, playbooks, and decision tables. Thank you for joining us today to learn about the latest in workflow automation. Your engagement and feedback helps us improve, and we look forward to seeing you in future sessions. Until next time, bye!